Well, thanks a lot. This talk is going to be a little bit more phonetics, probably than average, so patience or more interesting questions at the end, I suppose. So my talk is about essentially how listeners deal with the lenition in highly lenited Spanish approximants. I'm going to explain what these consonants are, and so I'm going to start by talking a little bit about lenition. A very, very common and basic definition of it is just like lenition would be a reduction process, a weakening process that affects many, many sounds. And there are many examples that are very well known as well for lenition. For example, Mistranslation of Stops. Normally, voiced stops can become aspirant approximants. In its vocalic context, for example, degemination, devocalization, deletion. And one of the typical or normal outcomes of lenition would be deletion. So when the unit is completely absent from the signal after it has been weakened. And then it's very interesting to realize that lenition is very, very common actually in informal and connected speech, which is the variant that is most typically used by everyone. Lenition is very, very common. So the question that follows is how listeners deal with information that is not very reliable from the signal. So when sometimes the acoustic evidence is not very clear or just absent. And it happens that often listeners just recover the units, apparently effortlessly, provided that some additional information is available in the signal. Normally, this information has to be semantic or syntactic, and then there are many examples, and there is a body of research on highly lenited units. So, for example, in Dutch, you have this derivation of suffix that can be reduced to this very minimal couple of segments, which is a segment, but then listeners report perceiving the segment regardless of whether it is in the signal or not, depending on how much information you have available. So the fact that listeners are able to recover units that are missing from the signal has some theoretical implications. One of the most relevant for my work is that it challenges lexical access models, which are they are models, they are explanation theories that attempt to explain how the route that information follows from an acoustic input up until when we represent, when we have lexical representation at a higher level. So the fact that then listeners are able to recover units that are not actually in the signal challenges models that attempt to explain how do we do that, how do we extract information from the signal and to eventually arrive to a lexical representation. I give an example here, but then I'll talk about this a little bit later. So some lexical access models, well, you can classify them in several ways. Some of them assume, for example, that underlying phonological sized units exist. So some lexical access models would assume that phonemes exist, for example, something similar. Those are normally termed abstractionist, and then there are different families. And then you have other models that don't necessarily require underlying abstract units, episodic. And then, for example, models that would require some models find it very hard to explain why in some occasions listeners seem to use lexical information to process lower levels of speech perception. For example, shortlist is a very well-known example. To summarize so far, listeners have to cope with lenition. Sometimes lenited units are completely missing from the signal. Nonetheless, listeners somehow are able to recover them most of the time, actually. So how does that happen? And that's essentially my question. And then so far, what has been done is that so researchers, what they have done is that they have presented listeners with varying degrees of information some acoustic information, very minimal acoustic information, and then they increase the amount of information available to listeners while they present them highly lenited units. For example, in this study from Ernesto et al. 2002, and see how listeners, when do listeners start perceiving these lenited units, and then normally these how they increase the amount of information, the amount of acoustic cues available to listeners or semantic cues is categorical. And then what we set out to do is to explore whether it is possible to see the fine detail of how listeners are able to start perceiving a lenited unit. And to do that, we are attempted to use continua from fully present consonant to fully absent consonant or a lighted consonant. And then we decided to use Spanish parent approximants because I'll explain in a bit. They are particularly suited to do this. For example, a continuum that you could use is, this is just one example, the word silent, which would be something like callado, that's an option. And then there's another word in Spanish, callao, that's the name of a port in Peru. So you can create a continuum from these two words. And the second word, the consonant is missing. So you can actually, if you present this continuum to a listener, you can start exploring what it is required for a listener to actually perceive this unit. And another thing that we decided to do is to see whether this is modulated somehow by the production domain. I'll refer to this again in a couple of seconds. As to approximate consonants, well, normal traditional descriptions of Spanish would say that the voiced plosive natural class, these are underlining plosives, and then you find them after pause, nasals, and D after L. And then elsewhere, you're going to find approximate consonants. At least this is the traditional account. And also, you would normally find accounts telling that there is a natural continuum from the presence of an approximate consonant in an intervocalic context, for example, to elision that exists in several. It has been reported for several dialects of Spanish. But then Chilean Spanish is a bit special, as usual. First, in that it's particularly lenited, so listeners tend to lenite and elide units, so you find less consonants than you would expect, in contrast to other dialects like Miami Spanish or Costa Rican Spanish, apparently. And then another important difference from the main traditional account is that the three consonants from the series, the bilabial, postdental, and velar, so in particular the and ga, behave very differently as well. I'm going to concentrate on the postdental da and the velar ga, and then the postdental is highly lenited in Chilean Spanish, and the velar is better represented acoustically normally. It's less lenited usually. This is how an approximant looks, a spherent approximant. This is something that's been called open approximant. As you can see, it's a transition between some vowels, but at least you can see a decreasing intensity and transitions. And then the next stage of lenition would be something that's been called vocalic approximant. Now we see a bilabial between two O's, O. And you can see that it's shorter, and the intensity decrease is less abrupt. So it's less present in the signal somehow. It's more lenited, and this would be a typical example of an enlightened variant. There is nothing in the signal that clearly shows that there is an approximant there where, and it should be at least underlyingly. This is the word todo. So in some conditions at least it should be there, but then it's missing. So what we did was, the first thing we did was run a phoneme monitoring experiment. And the idea is to present to listeners a continuum from approximant to elision. And then we used a modified version of this task without reaction times. We had 61 native monolingual listeners. And then we created a synthetic 10-step continua from open approximants to elided variants. So from full presence of the approximant to elision or absence, deletion. And we did that for the and for G. We used clad synthesis, and then we modeled these synthetic steps from natural examples. So it's a type of clad copy synthesis. And then one crucial fact from my design is that both words, as the example that I gave above, are legal Spanish words. So I'm presenting a continuum to listeners from an approximant that creates a word, and if you delete it, a different word becomes available to the listener. And I presented it in 4 conditions that varied informationally. The first condition was segmental, where I only presented the approximate consonant or its absence and the 2 surrounding vowels. And then the next condition was word level, so I would embed the continuum in a word level context, and the next 2 conditions where I primed one end of the continua. And the idea is to see at which point listeners start perceiving and reporting the approximant, what is required for them to restore this unit, even if it is absent. This is how the endpoints of a continuum could look. So at the left, you have the consonant present there in the word dudo, and then it's absent in the word duo. And these are different lexical items from different lemas, and the lexical frequency of the items was controlled as well. As to the results of this experiment, in particular this task, so I have to explain a bit these figures. You have in the x-axis you have the continuum steps from 1 to 10. These were 10-step continua, and then in the y-axis you have proportion of perception of consonants. So in the left-hand side you have how much the listeners reported perceiving D, and at the right-hand side how much they perceiving G. And then what is interesting is that in the case of D, in the yellow condition segmental, which was the condition in which they had less information available to them, only the approximate consonant and surrounding segments, of course a continuum from presence to absence, they reported perceiving the consonant even when there was no evidence for the consonant in the signal. So by steps 8, 9, and 10, there was almost no information in the signal. By step 10, there was absolutely no acoustic cues for a D in the signal, and then listeners nonetheless reported perceiving them. And then they didn't do that for G. This as I mentioned briefly at the beginning, this is interesting because, there is no reason. Like there was no acoustic evidence at the end of the continuum for D, so it's not that just the continuum was failed or something. It seems like listeners use their expectations about what's normal in production and perception to recover units that are not necessarily in the signal. We also run an identification task, which is crucially different from this task in that in phoneme monitoring, listeners don't necessarily have to process, they don't need to, it is not mandatory that they perform lexical access for this task, at least in the segmental level. But then in identification, listeners are provided with 2 labels that they have to process and take into account before providing an answer. So in this task, lexical access is mandatory before the stimulus is presented to the listeners. So we would expect that the phoneme monitoring would be a task closer to an auditory level, and identification is a higher level task in which there is more lexical processing. In essence, besides the instructions, the stimuli were identical, and the results were very, very similar. Perhaps the response distributions were closer to categorical perception distributions, categorical perception. So, for example, the the changes from sealing and perception to the chance level crossing are less abrupt. But then the overall pattern of G being a consonant in which it seems like the acoustic information is more reliable, and D in which it is less reliable, and thus listeners are able to recover, that still holds true. They are very similar, the distributions. If we see the previous graph, they are very similar. And then we also run a discrimination task. It had an ABX format in essence. That's maybe the only important thing I need to say. And then the results, in the case of G, they essentially show what we would expect. Higher sensitivity to differences in the stimuli for those that are close to the category boundary. And in the case of D, in the condition segmental, which is the condition in which listeners have less information available to them, very low discrimination levels, but as soon as we give the listeners more information, we give them a semantic context, and we give them, in the case of the prime conditions, an additional semantic prime. Discrimination sensitivity increases abruptly. How do we interpret these results? Well, first of all, in the case of D, we see phonological recovery. So listeners report perceiving consonants that were in the signal, and then also lexical effects on speech perception, because as soon as we provided listeners with, for example, a semantic level, the distributions became closer to a categorical perception account. I can explain why I think that's the case if you're interested. But then, in essence, this end of the continuum is a possible word, and this end is also a word. So as soon as they have the semantic context, you could argue that a lexical effect sets in for each one of these endpoints, and they compete and somehow transform the distribution in a categorical perception distribution. And there is more information available. These results are compatible with some views of lenition that see this phenomenon as a degradation of the informational complexity of the signal instead of just weakening or target undershoot. And to finish, they suggest a link between production and perception, in that, given that listeners seem to take into account what they find natural in production and perception, that is, in perception they would lenite often these does, so in their expectation in perception, they might use that information to recover units that are not necessarily present in the signal. And as to the lexical access models, it seems like this, given that listeners use the information that they think is not natural or expectable in production and perception, it seems like my results are better accounted for by models of lexical access that incorporate the experience of the listener in pre-lexical stages of perception, and episodic models seem suited to do that. And also by lexical access models that are able to account for lexical effects on speech perception.